So hi everyone, welcome to the webinar today. We're doing Dragonflies of the Sunshine Coast with Rand Rudland. We're just opening up the webinar right now. So just for your information, all of you are muted with your cameras off. We'd love to see you participating though. You can do that in two ways. The first way is via the chat module. Make sure that when you're sending a message out to us though, it's going out to panelists and attendees so that all the attendees can hear what you have to say as well. It's a great place to chat, say hello. Let us know where you're joining us from today. If you have a question for Rand that you would like him to answer within the presentation, please make sure that gets into the Q&A module, and then I'll be able to make sure that that gets put together in the questions section at the end of the presentation. So I'd like to welcome you all today. Rand is a well-known naturalist on the Sunshine Coast. He's also a great presenter and a wonderful photographer. So I'm certain this is going to be a wonderful presentation. Rand, I'm going to hand it over to you. Thank you so much for being here, and we're all looking forward to this a great deal.
Okay, thanks, Lexi. Well, yeah, welcome. We're going to take a look at the dragonflies on the Sunshine Coast, and we'll work our way through a few topics, and let's just see what we can do. So this is sort of the agenda for the webinar, and just to set it straight, let's get it on the table. I'm not an entomologist. I'm a naturalist, and I just do a lot of photography, and I try to learn about as many of the components of our natural environment as I can, and dragonflies sort of fit right into flying things, which I'm very interested in. So at the end of this, I don't expect anybody or everybody will retain all of this info. If you do, your memory is much better than mine. It will be available on the BotSoc site later on. So hopefully let's just work our way through these various topics, and I hope you find it interesting. So we'll look at the dragonflies around the world, just a quick run through, size range, evolution, some basic anatomy so you know what we're talking about, and then a look at the damsels and dragons of the Sunshine Coast. And then we'll finish off with just some of the resources that you might want to reference if you do develop an interest in these wonderful little insects. So first of all, a comment about viewing these odonates or dragonflies and damselflies. First of all, it's not easy. You certainly can identify a fair number just by your own vision, but binoculars make a big difference. And if you want to identify a lot of them, you either have to photograph them. And if you're going to photograph them, you need to get two views. You need to get, in most of them at least, a top-down or a dorsal view, and then a side or a lateral view, because most of the identifying characteristics come in these two views. And some of them, you also need to be able to look at the face. So it can be a bit of a challenge. The other thing that you can do is you can catch them. Butterfly nets work very well, but it takes a lot of practice and a lot of time in the field to be able to catch these things, because they can fly at quite a high rate of speed. But it's worthwhile if you catch them. I tend to use tennis ball containers as the viewing platform. Catch them in the net, put them into the container and have a look at them, and then let them go. And if you are trying to get up on, sneak up on them, coming up from behind is about the only way you have much chance of getting really close. It's the only area that they don't see very well. So just to give you an idea of what is out there in the way of butterflies, every orange square represents a varying number of sightings in iNaturalist. You can see on the bottom there's over 1 million observations and 3,000 species that have been photographed and identified in the world. You can see they don't go too far north, but some of them do get up into the copper mine area and into Inuvik and in North America at least. It's interesting though, this is only a fraction of what's actually out there. There's well, somewhere around 7,000 species of dragonflies and around 2,900 species of damselflies in the world. So this is by far an incomplete presentation of what we really have to go looking for if you're traveling. So some of the species around the world, you'll notice the colors. They're pretty standard colorations, but the combinations of colors are quite unique. Some of them are brilliant. So in Solomon Islands was just the most amazing coloration. Interestingly enough, the female is a brilliant yellow, same species. And then the skimmers, we'll see some of those on our local patch. Not too different in their colorations, but the combinations of characteristics make them quite different. And then the size range is most impressive, because if you look at our smallest species of damselflies, the forktail, it's 3.5 centimeters, and our largest dragonfly is 10 centimeters. And then if you go to Panama, you'll see the helicopter damselfly if you go into the forests. And just to give you an idea, there's the relative sizes of these three species. So it's interesting that the largest of the three is a damselfly, even though our damselflies are quite small. So just from an evolutionary perspective, the ancestors of the dragonflies go back into the Paleozoic, and some of them were huge. It's interesting that that era had very high oxygen levels in the atmosphere. And some of these dragonflies reached a wingspan of around 2 feet. And it was only because of the high oxygen in the air that they were likely able to actually generate enough energy to fly at that size. So it's a pretty historical group. They go back a long ways. So a couple of comments on general anatomy. Basically the standard insect anatomy, you have the head. They don't really have a neck per se, but they have a connection between the thorax and the head, and then the abdominal segments and the appendages on the tip of the abdomen. On the left-hand side of the screen, you see the pterostigma. This is an important landmark, and most people and most references when you're looking in the books, you'll often see stigma as the shortened form for this. The nodus is sort of the wrist, it's the middle of the wing, and is an important landmark to be aware of. And the eye, of course, massive number of micro eyes, if you will, ommatidia. And they really can see almost in all directions at any one time. So that's why they're difficult to catch up with. The final segment, number 10, is sort of the business end of the male and the female. You can see the 10th segment is the one in the yellow box, and the appendage is attached to that. So this is the area that, especially in the damselflies, it's really important to get a photograph of if you actually want to get it to species. So yeah, this is the basic dragonfly anatomy. If we look at the damselflies, it's not that different. Same number of segments. The striping on the thorax is interesting because it often will help with the identification. And so these are the standard terms that you'll see in the references for the thoracic stripes, and the numbering of the abdominal segments is the same. One thing that you can see on this photo are these so-called post-ocular spots, behind the eye. And this one forms a dumbbell. You can see that connecting line. And so whether or not there's a dumbbell or just the spots is an identifying factor in some species. The appendages, these are drawings. I'm not an artist, obviously, but you get the idea. And the shape of the upper and the lower appendages determine your species, especially in the damsel and in the damselflies. So you can imagine how difficult it is to get a photograph that shows that. But if you persevere and try to get directly behind and above, you will be able to occasionally at least get a good enough look to help with the identification. So what's the difference between damselflies and dragonflies? So these are the main factors that we'll look at. The wing position, the wing shape, the body shape and size, and the eyes. So if we look at the wing position, dragonflies are much larger and have much more muscle mass in their thorax, so they can't lift their wings up over their abdomen like the damselflies can on the right. So if you see a large dragonfly that's sitting with its wings flat out like on the left, this is a dragon. The two on the right are damsels, and the one in the middle, you can see the wings are folded directly over the abdomen. And on the far right, the wings are at 45 degrees and they're much smaller. So this is called the spread wing, and we'll talk a little bit about that. But that's one major difference for identifying or separating these two groups. The wing shape, another key differentiation. The dragonflies on the left, the hind wing and the forewing look, the bases are entirely different. If you compare that to the bases of the dragonfly on the right, you can see they're basically the same width. So that's a pretty easy one to look at. And then the body shape and size. We sort of referenced the size in the first section there, but to give you an idea, this, the dragonfly on the left, 55 millimeters, and the blue A damselfly on the right, about half the size. So you can see the difference in the size of the bodies, much more robust in the dragonflies. And this is not photoshopped, but I thought it was a pretty good way to describe or compare the two groups. So the western pond hawk, the green large dragonfly, and what this damselfly thought it was doing, I'm not sure, but the camera was ready, so the photograph is proof that there's your size difference. So the other identifying characteristic is the eyes. On the left, you see the very large, in most cases, touching or nearly touching in the midline. On the right, you see the damselfly, and they're much smaller and they're separated. They never touch in the midline, and so that's a very strong characteristic that you can rely on. And they can be photogenic if you can get them to look at you long enough. This one actually on the right, you can see that there's actually some other kinds of eyes. They don't just have the large compound eyes, but if you look in the middle, you'll see these three ocelli, which are used for different purposes. So they're very small, but obviously functional. And one other. Then there's a characteristic called a T-spot that you will use in some of your larger dragonflies in the mosaic darners. You'll see these T-spots have different shapes. And the striping on the thorax, if you look on the right-hand photo, you'll see the frontal stripes. This is considered the front of the thorax. And below that is the side or the lateral thoracic stripe. And we'll look at those in more detail. So yeah, these, they also have small antennae. They're very difficult to see, but they are there. And they're used to assess temperature and moisture, and also probably smell. So certainly a multifunctional head. The other thing, if you're looking in the reference books, you'll sometimes see a reference to a structure that shows on these next 3 slides, and it's called the anal loop. And it's this shape that's outlined in red, and they take quite different shapes in different species. So if you think of this one, and then so this is a mountain emerald. And if you look at this one, this is a Black Meadowhawk, and you can see a totally different shape in the anal loop. And then if we move on to, this is actually a microscopic view of a chalk-fronted corporal, and you can see there is the anal loop. Again, quite a different shape. So not to remember them, but if you're doing photography and you're having trouble identifying a species, you may be able to get some assistance by looking at the shape of the anal loop, whether it's got a toe or whether it's stubbed, or any number of combinations that can be used. So the other complicating factor with the odonates is that they're not consistent in their color as they move through their lifespan. This is the same species at different times in its life. The one on the left is early. And the early stages we term Teneral, Teneral. And so you'll see as they age, many of them become this grayish or prunose coloration that you don't see in the juveniles. So just be aware that it's not as simple as saying, oh, there's an adult chalk-fronted corporal, for instance, because when it was younger, it didn't look that way. So where do we find these things? I guess the answer is pretty much everywhere. Pond edges are very common. Obviously, if there's lily pads, there's many species that lay eggs on them. This is McNeil Lake, a great place for dragons. And gravel roads around ponds seem to attract many individuals, partly I think as the heat assists their body temperature regulation. Forest openings will have certain species that go there. And for those that saw the butterfly presentation, we talked about some of the species that hilltop. And it turns out that there's also some dragonflies that hilltop. The males will patrol at the top of, say, Pender Hill, and wait for the female to come up. They'll mate, and the female will go down to find water to lay the eggs. So even at the top of the mountains, you'll see various species. So this is one of the darners, a California darner, and it's actually laying eggs on a lily pad, the small yellow objects that you can see. One is actually extruding from the tip of the abdomen. And so that's the beginning of the process. And if we look at the life cycle, and just go through the sequence. So the darner at the top, and you have a damselfly, and you can see the difference. The damselflies, many of them have injectors that allow them to inject their eggs into the vegetable matter. And so you'll see them with this configuration where the looped abdomen, they're actually inserting an egg into the stem of the of whatever they're able to find on or near water. So the eggs develop in the water. They go through many molts. The nymphs, when they get to full adult size, come out of the water and attach to some structure, either solid wood or anything basically that's above the water level, and they attach on. The skin on the back splits and the adult emerges. And so you've actually got in this top right picture, you've got the larger dragonfly, exuvia, E-X-U-V-I-A is what it's called. And the smaller one on the bottom right of that photo is a damselfly exuvia. So you can see the relative size of these two groups. From there, we see the Tenerals, as I referenced earlier. These are the very early stages. They're basically sitting, drying their wings, pumping fluid into their wings to get them fully expanded. They don't really have much coloration, and over time they'll develop their adult colors. So here's an adult damselfly, spread wing. Would have started out with much less coloration. Then the mating process starts again, and they lay the eggs, and that's the life cycle that we're looking at. And you'll see these all of these life cycles, other than the larvae, they're a bit difficult to find unless you net in the water. But it is possible. This one was actually walking across a gravel area on a power line in Half Moon Bay. It had just come out of the pond and was looking for a place to basically become an adult. So let's look at some of the damselflies. And what I hope you take away from this is not the specifics of each one. I mean, there are some that are easy enough to identify, but just take a look at these three, and you can see that there's some significant differences in these three groups of damselflies. The one on the right, well, start with the one on the left. It's got its wings spread, so that's a spread wing, and you'll never make any mistakes in putting that into its right subgroup. The one in the middle, you've got alternating blue and black segments in the abdomen. The only species we have here are the blue A's. We have three species of blue A's, and we can look at them a little bit, but they're very difficult to identify other than by having a look at the terminal appendages of the male or a microscopic view of the female. So for most cases, we're not able to separate these out. And then on the right, the fork tails, you can see there is just solid black abdomen except for the 8th and 9th segments, the segments that are blue at the tip. So you can put at least into one of these three subgroups when you're looking at damselflies. In the spread wings, again, we don't need to go into too much detail here. You can see along the bottom the shapes of the male appendages. You can see that the middle one might be the easiest one to identify. The male and the female both have small dots on the lower lateral side of the abdomen by the red arrows. And if you can see that, and you often will be able to with binoculars, that identifies the male or the female. So you can, try and get your photos if you're able to, but at least you can say these are spread wings. So this is the northern. And you can see on the right, the injector here that's used for inserting the eggs into the vegetation. The blue A's are as I said, significantly more difficult. You can see by the drawings, the lateral on the top left shows this typical outline, and the photomicrograph on the bottom left is, you can certainly compare those two and see. And then if you want to look from a top-down perspective, the middle photo and diagram, you sort of get an idea of what you're looking at. So these are difficult to identify, but if you persevere and get the right photos, or if you find a dead one somewhere on the side of the pond, you can look at it under a microscope. Even on the highway, actually, you'll often see roadkill, so you can pick those up and take them home as well. Northern blue-A, not going to go into any detail. You can see the differences. In this one, it's this hook on the dorsal appendage or upper appendage. The fork tails, these are the ones, as I said, that have all dark abdomen. Most of them have white rings separating the segments, but the tip of the abdomen in the males is always blue. The females always, or mostly at least, have orange in some configuration, and that's just a matter of spending some time trying to sort out which of these configurations you've got. I will say the one that you can most easily identify is the Pacific, because it's the only one that has 4 spots like this, well separated on the top of or on the front of the thorax. So you'll see these if you go to Smuggler Cove, and on the walkways in Smuggler Cove, especially the first one, you will see these by the dozens, and it's very easy to make that identification. So the larger group in number and size, obviously, is the Dragonfly group. And the largest group of those is the group called the Mosaic Garner group. And so there's some that are common and some that are uncommon, and that may be simply just a matter of our time in the field. But from my experience, the ones that you're looking at here are the least common on the coast. And you'll see the red circles really are the primary way of identifying the different species. And if we look in more detail at some of the more common ones, this is the variable darner. And looking at the lateral thoracic stripes, you'll see some variation as it gets its name. The one in the middle, they're connected. The one on the left, the spots are separated. And so this is where it gets its name, variable. And we do get both forms, although the spotted form, the one on the left, seems to be more common. And then the female down in the bottom right is sort of in between, I guess. So this one you will see quite commonly on the Sunshine Coast. Paddle-tailed, this is one of the quite common ones that we'll see soon. The tail is, well, it's not the tail, but the terminal appendages are very distinct. The lateral thoracic stripes are also very distinct. And so this one you will expect to see. And what you need to notice is that on the 10th segment, there is a blue spot. Because when we look at the next species, which is also fairly common, the 10th segment does not have a blue spot. So this is the the black tipped, and this is what or how it gets its name. Now clearly the appendages are quite a bit different, but from a distance that may not be readily seen. So the characteristics, you see the lateral thoracic stripes here are, I use the term boxy. They're quite linear. They don't have much in the way of indentations. They're fairly straight. And so that's another characteristic for this species. California darner is usually our first species out. It's been out quite a while now, and it's the smallest damselfly that we see, and it has a black facial line. So it's one of those things that we look for in the field, but it also has the blue spots on S10 on the 10th segment, and it's unique in that this spot behind leans backwards, if you think of it that way. In most species, the tips of these lateral thoracic stripes end up very near the bases of the wings. But in this species, you see that they go quite a bit rearward or posterior. This is the male California darner. So the other one that's out now is the blue-eyed darner, the male and the female. And this one is quite distinctive. It has this brilliant blue set of eyes. And as you can see, the male appendage is very distinctive. So this one, you can identify this one in flight. And the eyes are so brilliant. The face is brilliantly blue as well. So it's the only one that we have that has basically an all blue head, if you want to think of it that way. The other darner we see, and certainly our largest darner, is the common green darner. And they often lay eggs in tandem. The male will stay attached to the female on the back of the head. What's interesting is this is one of the species that they will actually totally submerge to lay their eggs. This is, I suspect, is some protection from predation. If their eggs are below water level, they're less likely to be predated on. And in this case, the female of the species will dive underwater and stay there for some period of time before they come up. Sometimes they are not strong enough to break the surface tension, and you'll see dead dragonflies and damselflies on the surface of the water. And often it's because they weren't able to recover from their submerged egg-laying process. One of the more common, no, I shouldn't say that. One of the more readily identified species that we have is this spike-tail. There's no other dragonfly on the coast, well, actually probably in British Columbia, that has this dramatic black and yellow combination on their abdomen and thorax. So we've seen this one in the Dakota Ridge area, and we've also seen it on the power line access above the airport. So it is around. It's not common by any stretch, but it is around. This is one that has been elusive until this year. There are very few places where this one has been recorded. There's one up in the Egmont area, one area up in the Egmont area, and one has been found just again north of the power lines by the airport. And so this is the spiny basket tail, and this was really a surprise to find it here, and thanks to Arnold for locating this one. What's interesting is that they lay their eggs in these egg masses. And so what happens is the female will go along the surface of the water and lay out these strings of gelatinous material encasing the eggs. And when they hit the water, they expand the matrix, and the eggs are suspended in that matrix and develop to the point where they can move on to the free swimming stage. So if anybody is out in any of the smaller lakes and sees a bluish mass of eggs, please let me know, because there's a good chance that this is the spiny basket tail, and it would expand their range dramatically. So keep your eyes open.
Rand, just a question. How large would you expect that mass of eggs to be? Are we looking for something the size of a dime, the size of a quarter, the size of a toonie?
About 6 to 8 inches.
Oh, wow.
Quite large. You can see it from quite a distance away.
Okay, awesome. Thank you.
Yep. So the more common emeralds, and the emeralds get their name from their face and their eyes. They are a brilliant green. After you've watched enough of them, they also have quite a sort of a unique flight posture of their abdomen. They tend to curve it a little bit, which most of the others don't. So this is one of our more common emeralds, and you can see it's got the ring at the base of the abdomen here. So that's a good one to look for. The mountain emerald, yes, it's found at higher elevation, but it's also found, again, this one's been found above the airport on the power lines. And this very distinctive terminal appendage of the male, you can't mistake in that one. But again, you can see how they get their name. They have emerald green eyes, and there's also emerald patches here on the front of the thorax. The other emerald, this is a new one last year, ringed emerald. You can see how it gets its name. Rings separating each segment. Very, very distinctive, and can be seen actually with the naked eye. And the other new one last year, I was up at one of the higher elevation lakes, and this one was flying by, and it just looked a little different. So I was able to follow it and get it on the ground, and this very distinctive brush tip. It's the only one that we have that has the brushing of the male appendages. So keep your eye open for that one as well. So the next large group, and probably the largest group, are the skimmers. And these are the ones that have what I'll call a flattened or a wide abdomen. And many of them are identifiable just by sight. Certainly this common whitetail is out now, and the male at least is fairly distinctive with that prunos or bluish abdomen, and the twin dark spots sort of in the outer third of the wings, but the clear tips. So that's the male. On the right, you see the complication comes when you get the young ones. The female has a slightly different wing pattern. It has black tips. So that's, you can get fooled for sure, because this one also has black on the wings. But the 8-spotted skimmer, certainly the male, you can see the 1, 2, 3, 4, 5, 6, 7, 8 black spots. The males have this gray outlining of a matrix in the wing. So that one makes it clear that it's a male. The female of the 8-spotted basically has a similar wing pattern, but you can see on the abdomen these parallel lines of yellow markings. They are present to some extent on the male. If you look closely, they were there when the male was younger, but the abdomen has changed and become prunos with age, and basically covers up those markings. So if you just compare these two species, the 8-spotted and the common whitetail, you can see where you could get fooled if you weren't careful with the lighter or the browner members, the early flyers, if you will. So just be aware to be really carefully looking at what the wing patterns are. That's your biggest help. So here's the comparison of those two species with the males. So once again, the wing pattern is the clear giveaway. So the other species that we see that has a fair amount of prunosity or blue fading as they age is the chalk-fronted corporal. This species is out now as well. You can see clearly the right-hand young specimen has no major coloration to it yet, but it will, and over time it will change, over weeks probably. What you should notice here too, and I haven't alluded to it, but the terminal appendages are really important in identifying. So if you look at the right one, this is a young female. This is very wide, and this one on the left, the male, is quite narrow. So the different shapes of the appendages will also help you narrow down whether it's male or female. 4-spotted skimmer is probably one of our most common that we see. The spots in this case are the 4 dark spots here, 1, 2, 3, 4. The stigmas do not count in that count of 4, and they're never counted as part of the markings. So here's where it gets a little bit complicated in a couple of species. So to identify a couple of the meadowhawks, you have to look at a structure that's called the radial planet. And it's basically identified if you go to the nodus, which is the arrows, and follow inwards, you will see this structure that's outlined in yellow. And on the right, you see that this layer of cells here is single in both wings, the hind wing and the forewing. Then if we go to the slide on the left, you can see that this group of cells is doubled in both the forewing and the hind wing. So the double row or the single row allows you to separate out 2 species. So let's look at those 2 species. So the belted whiteface has a single row, as we talked about earlier. So this is the belted whiteface. If you look at the other one, this crimson ringed whiteface, it has a double row of at least some cells in both front and back wings. And so this is the real difficult one to tell apart. So, good luck with that. Almost impossible in the field unless you get one that's sitting for any length of time, and they don't usually do that. This is a definitive way to separate the two. One of the other white faces is the Hudsonian, and this one is also out now. And it's primarily identified by having no markings on the wings, and these sort of middle of each abdominal segment has these decreasing length red spots or reddish orange spots. So this one is it's with us now, and they do settle, and usually often enough to get a good look. This is one that I know is here because I've seen it once, but I've not been able to get a photograph of it on the Sunshine Coast. This photograph is actually from the Creston area, but it is here, and it's very distinctive. There's no other species in British Columbia that has this black abdomen with a single yellow spot on it. So this is another one that if anybody sees any like this, please let me know, or ideally get a photo of it so we can include it in our library. And I'd love to know where you found it. I found it on the power lines in Half Moon Bay, probably just around the area west of the Big Tree Park. So that's the only area I've seen one. The Western Pond Hawk, we saw a photo of this earlier. The male and the female do look a little bit different. The ones on the bottom are the males, and they tend to go prunos with age, whereas the female tends not to. And you can see the one in the top right, they're very aggressive in their feeding. I mean, here it's got a fork tail, probably a Western fork tail in its grasp, and they will take even smaller dragonflies. So it's a dog-eat-dog world in the dragonfly world. This is one of the more beautiful, I would say, meadowhawks, variegated. You can see the difference in the colorations of the, at the different stages. Notice that there are some very small spots on the bottom here of the ventrolateral thorax. And here, again, looking at the stigma, you see this black border to a red stigma. That's classical for this species. This is one of our only migratory species. So males will often show up in the early spring, and you'll often see them a long ways from the water. I've seen them at the top of Pender Hill, for instance. So they are hilltoppers, as I referenced earlier. This group of what I'll call the red meadowhawks is certainly one of the most dramatic. Can also be a little bit of a challenge from an identification perspective, but can be a lot of fun. So cardinal meadowhawk, you can see, has basically solid red abdomen and these very small stripes and a sort of reddish face. Moving on to the next one, the autumn meadowhawk. Looks very similar, but it has yellow legs, whereas the previous one had dark legs. And this one really has a distinct scooping on the female for egg laying. So this one you'll see more later on in the year, but these are the identifying characteristics. Red veined is very rare. I'm not going to spend a lot of time on this, but just look at the abdomen Actually, just go back one. There is a hint of black along the edge. Saffron winged, again, uncommon for us here, but you can see how it gets its name. The leading edge has this saffron coloration to it of both wings. And again, a black margin on a long stigma, a long red stigma. The striped meadowhawk actually lives up to its name quite well. If you look at the tail and the lateral thorax, this one you will identify readily. Note that these black markings, these so-called sawtooth markings, don't extend to the very tip of the abdomen. So that's the striped meadowhawk. The white-faced meadowhawk, this one is relatively easy to identify simply because of the white face and this very distinctive sawtooth that extends all the way to the tip. Cherry-faced, this one actually was a new one last year as well. And it has a reddish face, cherry colored, if you want to call it. But it also has a slightly different abdominal pattern. And so if you compare those two, the cherry-faced on the left and the white face, their abdomens don't look that different, but the faces are clearly separate, able to separate out the two species. The other meadowhawk that we added last year was the Black Meadowhawk. Lives up to its name quite well. Very distinctive. No yellow spot on the abdomen as we saw earlier. A blue dasher is a common species. Mostly you'll find it around the ponds, on the edges, on the logs. And it's really readily identified because it's the only one that has a white face and these green eyes. So the adult male on the left bottom is quite distinctive. The earlier forms in the female are a little more difficult, but you can see that double row of yellow extending down the abdomen is diagnostic for this species. So a few thoughts on the ID process, because it is a challenge. Males and females look different in all species, even if it's only different at the appendage level, but usually it's more noticeable than that. Differentiate the males from the females by paying close attention to the shape of the abdomen and the appendages. And what you'll notice too is that the abdomen often is much heavier in the female. So just be observant of that. Pairs in tandem or in copula usually provide an opportunity to observe the characteristics of the female. And I say usually because occasionally the male will make a mistake and couple with the wrong species. They won't necessarily be successful, but if you catch them in that situation where there's two different species, you might mix up your identification. And early on, concentrate on the males. They're the ones that you're most likely to be successful with early on. And then associate the females that you see with them as you move up your learning curve. And think that many young males look similar in color, at least, to adult females. And this, as I have shown, is quite a challenge sometimes. And finally, color variation, from Teneral to late adult, including eyes and face. So it can be very useful to, just be aware that these colors change as you move through their life cycle. So quick comment on dragonfly flight. First of all, they're darn hard to get a hold of on a photograph in flight. they can move forward at 100 body lengths per second and backwards at 3 body lengths per second. So they're pretty quick. They do have some limitations. They can only hover, especially if it's warm, for a limit of time because they get overheated. So some of them at some point will have to settle, but it certainly can be difficult to find them. It's interesting if you look at where their legs are. If you look closely at them, you'll see that they stick the front portion, the leading portion of their legs up behind their neck. So I'm not quite sure why that is. Maybe it's to stabilize the head. I'm not quite sure. So let's just finish off by reviewing some of the resources that are available. These are the 2 books that I tend to refer to the most. Rob Canning's, I was fortunate enough to know Rob at university, and he's been very helpful in the identification of some of the species that I had trouble with. So thanks to Rob for that. And his book is available, and it's a very good book to look at from an overview perspective for British Columbia. The one on the left, Dennis Paulson, this is a much more extensive book, very useful, and I rely on that one primarily now for more detail. So that's a very good one to have, and both of them are useful in their place. The other resource is iNaturalist, and anybody that knows iNaturalist may be aware of this, but I've started the Sunshine Coast Biodiversity iNaturalist project, and one component of that is the dragonflies and damselflies. And you can see we've got 42 species, 73 people have contributed identifications, and 32 people have observed. And we're probably well over 1,500 observations of dragonflies and damselflies on the Sunshine Coast. So that's a really good site to visit. It also, if you're interested in any other life form on the Sunshine Coast, it is part of that overall biodiversity umbrella project. So worth taking a look if you have other interests. The other one that's really good is a Facebook site dedicated to Western odonates. This is one where you can actually post a photograph and give your best guess at the identification. And if you're wrong, somebody with much more knowledge than we have will correct you very politely. And it's a great place for learning. And it really restricts its observations to Western Canada and the Western US, so quite appropriate for us. The other one is eFauna BC. Rob Cannings was heavily involved in this, and the site really has a lot of data on dragonflies and butterflies and virtually every other insect and living life form in the province. So eFauna is a good one to go to as well. And then just a plug for the very local one. I put out this brochure a couple of years ago. It's already 3 or 4 species out of date, but it's a good pocket guide. It's got photos on the one side. It has all of the stripes that you need to know the patterns of for identification, which is important. And on the back side is a detailed description, written description of all of the various species. So yeah, that's pretty much the end of what I've got to say. So if there's any questions, I may be able to answer them.
That was amazing, Rand. So to our participants, if you have questions for Rand, go ahead and put them in the Q&A module, and we'll try and get them answered best we can. But otherwise, that was a broad-ranging, really informative. You had kind of the basics of what someone like myself, a true beginner, is needing to look for, and also some really, really technical information of the rare ones that more experienced Audinets lovers would be needing to look for. So that was great. Thank you. So I have actually a question for myself. So the flight times for dragonflies and damselflies and what have you on the coast, when did they start flying and when did they stop flying?
It's really temperature dependent.
Okay.
So, you know, when the temperature gets up into the sort of mid-teens, we can often start to see the first species in the air, which is not that different from the butterflies, really. They probably lag the butterflies by 2 to 3 weeks. So, you know, as early as March, April, we'll
Okay.
start to see them if we get a warm day or, you know, a series of warm days. If anybody's interested, I do have a spreadsheet, a visual of the flight times that we know of to date. I can actually get that to Lexi. It can be put on the website if that would be of interest.
Yeah, that would be amazing, actually. And if you could send the butterflies one over as well, I'm not sure if we have that posted to the website, and we'll get it up there too.
Yeah, and just to be aware, these are obviously uh, a dynamic process because we're always updating them. So from year to year, depending on the temperature and how early it gets warm, we may be able to move the first sighting dates earlier. We certainly did that this year with some of the butterflies, but later with some of the dragonflies. So.
Yeah, absolutely. Living documents, and appreciate the fact that yourself and a few other naturalists on the coast are kind of putting this data together. So in terms of their flight time during a day, if I want to go out and I want to look for dragonflies on the Sunshine Coast, am I doing it like birds by ear? Am I wanting to be there first thing in the morning? Do you find that they're really
Yeah.
showing up as the day warms up in the middle of the day?
Yeah, middle day.
Middle day, nice and warm?
It needs to ideally. I sort of use 17 degrees as sort of the cutoff. If once it gets to 17, then I'm pretty comfortable that something's going to be flying. You may get the odd one at a lower temperature if it's a well sunlit area, but I tend to start around 10, 11 in the summer. But that's an interesting point. If you are really keen and want to see some interesting stuff, you go out very early in the morning when they're still attached and warming up.
Okay.
And you get some really interesting sightings of dragonflies in particular with dew on them, just soaked in dew. And actually, there's some very good photos of that on the Western Ode Nata Facebook site, if anybody's interested. So you can look for them and find them. They're difficult, but if you do find them early in the morning, they're very docile because they can't fly. They're too cold. And they just sit there waiting to warm up. And as the dew evaporates, then eventually they get warm enough to fly.
Cool. And so if you had kind of 3 accessible locations on the Sunshine Coast where people could go and look for these critters, what would your recommendations be? Besides the Sunshine Coast Botanical Garden, of course.
Yes, yes. Well, one very good location is a small beaver pond on the power lines up towards the Big Tree hiking trails, just south of Trout Lake. If you go up towards the Big Tree stand, just before, let's see, I'm going to say it's 600 meters past the power line, there's a small road that drops down to the right on an angle, not the 90-degree road, but the 45-degree road, and it's about 500 meters from there to a pond, and that usually has excellent dragonflies. You can walk it from the road. If you have a low vehicle, don't try to drive it, but it's a short walk. And you'll often pick up dragonflies all the way along the gravel road as well as butterflies. So that's one. The others, there's an area, any of the power line ponds are very good. So the area north of the airport has some interesting trails. You can drive up towards, above the airport, I guess, take the turn that turns off the road to Dakota and go up behind the airport. That area is good. The parking area by Trout Lake later in the year also often provides easily 6 or 8 species starting in late July, mid to late July. So those are three that come to mind. Sergeant Bay Provincial Park actually is another one that has a good representation because you can get very close to the water down by the fish ladder. So that's another one that comes to mind. Where else?
Those are some great locations for people who are new to this to kind of go check out and learn a bit more about it. So you mentioned Sergeant Bay Society and also the Sunshine Coast Natural History Society. I know a lot of this information in the brochure were put together in collaboration with those organizations. So they're wonderful ones to check out. And again, this is the last spring presentation for the Sunshine Coast Botanical Gardens webinar series. Rand, I can't thank you enough for your information, for taking the time to share all of this with all of us, and your beautiful photographs as always. Thank you very much. Thank you for your help, and wish everyone a happy day, and we'll see you all out in the field.
All right, in the field,
Yeah,
in the sun.
wonderful. Can't wait.
Okay, bye now.